Section 4.3.1, harmonic motion. So this is just an extra warm-up problem that if you feel like you need some extra practice, I'm going to go through. This is the steamboat problem. So Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, a point on the paddle blade moved in such a way that its distance d from the water's surface was a sinusoidal function of time. When his stopwatch read 4 seconds, the point was at its highest, 16 feet above the water's surface. The wheel's diameter was 18 feet and it completed a revolution every 10 seconds. We want to sketch a graph of the sinusoid. So for this, we have to kind of pick out some key features that we just talked about. So we know that for this function, it says that when his stopwatch read 4 seconds, the point was at its highest 16 feet above the water. So that then tells me that I have a maximum at 16 feet. And again, the time for when that happened was a time equal to 4 seconds. Then it says for the next part that the wheel's diameter was 18 feet and that it completes a revolution every 10 seconds. So if the wheel's diameter is 18 feet, so from the top part to this part here is 18 on the wheel, and if we know that the maximum point up here reaches 16 feet, then that means we have to have 2 feet below water. So the minimum would be equal to -2 feet, because that's going to stand for below water when we have the negative values. And then for the next part, we want to figure out, of course, what our amplitude is equal to. Our amplitude, if the diameter of the wheel is 18, would have to be equal to 9, or you can take your maximum and then you could subtract it from your minimum. So 16 minus -2 would be 18 divided by 2. That's how also you can get your amplitude. Your vertical shift is equal to, of course, your maximum plus your minimum divided by 2. So that would give us a midline of 7. So then for this, we know that the period is equal to 10 seconds because it said up here that it completes a revolution every 10 seconds. And then recall that we know that the b value times the new period is always equal to 2 pi. So if I solve for my frequency, we would get b is equal to 2 pi divided by the period. So in this case, 2 pi divided by 10 is equal to pi over 5. So that's something we're going to need after when we write our equation. So let's go ahead and start to sketch this as a graph. So on my graph, I know that the maximum is at 16. And then we have our midline here at 7. And then the minimum our graph goes is -2. So for my graph, I know only one part. So it's very important that you note that the only part we know so far is that at 16 feet, that was at time equals 4 seconds, because it doesn't tell us where we start at time equals 0 on the stopwatch. So for this, I know at 4 seconds, I'm at my maximum up here. And if the period of my graph is 10 seconds, remember we talked about the key points being taking the period and dividing in 4 equal parts. So I know that is going to go by 10 divided by 4 for my key points, which is 2.5 seconds. So if I add 2.5 to 4, I get 6.5. And then if I add another 2.5, I get 9. If I add another 2.5, I get 11.5. And another 2.5 would give me 14. So then at 6.5 seconds, I would be now at 7 for my height of the wheel, so 7 feet out of the water. And then at 9, I'm going to be here at -2. And then at 11.5, I'd be back at my midline 7. And then at 14, I would be back up here at the highest point. So, because when we start here, we go to our midline, then we're under the water, back to the midline, and then up here at the highest. So for this, this would give me my graph of the sinusoidal function. So then for B, it says we want to write the equation for this. So remember our general equation, y is equal to, and I'm going to use a cosine graph because we have a maximum starting here, a times the cosine of b times x minus c plus d. So we already found our amplitude and our midline, and we also found our b value. We just need to make sure we know what the phase shift is. And if we're starting with a cosine graph, we would start at this maximum point right here. So our phase shift would be moving our graph to the right 4. So one possible equation is y is equal to my amplitude, which is 9, times the cosine of pi over 5 times x minus 4, and then plus my midline, which is 7. So this is one possible equation that I can have. Of course, we've already talked about how we can have multiple equations because I could have started my graph here at a minimum instead. If I started there, then my phase shift would be instead 9, and then I would have to have a reflection across the x-axis, so I'd have a negative in front. Or I could start here, and then if I started there, my phase shift would be 14. Of course, you could also have a sine graph. If I had a sine graph, I would have to start on my midline, so I could have started here or here. If I started here, it's going down first, so I'd need that reflection. If I start here, it's going up, so I could use that for my graph. So now that I have that, I can answer the other questions. It says how far above the water surface from the point when Mark stopwatch to reach, 5 seconds and 17 seconds. For these, you would want to use your calculator to help. So if you plug this into your calculator, y equals, so you would want to make sure that your mode is in radian mode, which I am. So now that I have that, I can change my window. So I would want to use my minimum. I did it as -5 to 15. And then I did my y maximum from -5 to 20, just so that I have enough to look at my graph. So here's what my graph looks like. And then for this, we're trying to figure out at 5 seconds and 17 seconds where we are. So I can just go to second trace and number one's value. And so the x value we can use is at 5 seconds. Our y value would be 14.28, so 14.28 feet above the water. And then if I did second trace again value, and we did the value at 17 seconds, our height, and oops, it said error because remember my window is only going to 15, so it actually need to change that so it shows on my graph. So let's go back to the graph for that. I could also go to my table if I wanted to and look at the values. So second trace value, and let's do 17, enter, and I get 4.21. So, or 4.212, or excuse me, 4.22 feet above the water. So again, you could also go to your table and just scroll down if you wanted to. It's just kind of a preference thing. So the next question says, what is the first positive value of time for which the point was above, was at the water surface? At what time was it going in or out of the water? Explain. So if we go to our graph and look at this, that means I need to figure out what's going on at this point right here. So if I zoom in at that point, so I'm gonna move my cursor all the way over there to zoom in. So if I zoom in there to just get a better look at what's going on, I'm trying to figure out at what time right in there we have our point, because we want our first positive value. So if I go to second trace and I'm going to look at the 0, so I have to do left bound would be, in this case, because my graph's down here, something to the left of that point would be below the x-axis. Something to the right of that point would be above the x-axis. And I'm going to hit enter for guess for that because notice my two arrows are in between. So if I hit enter, I get 0.0817 seconds. So at 0.08 seconds, we know that it's coming out of the water because it's going towards a maximum value. And so that would be your answer for D. So again, just to look at the answers, I'm going to go ahead and write them down. So here's the solutions that we just came up with. And again, for D, we were just saying when 0 is equal to this, we were solving for x, and we used our 0 function to get the 0.0817 seconds. So I'm going to go ahead and do the other problems as well so you guys can check those too.